So, analog circuit testing, A to D and D to A converters. So, there are many analog parts. So, we have operational amplifiers, we have comparators, analog comparators. Once you have op amps, you can build other things like oscillators, filters, analog filters. You can build I mentioned oscillators already, right? Oscillators, there are also some power management circuits. For example, we can have the converters, power converters. So, power converters can be buck converters, boost converters. Okay. So, these are all examples of power related circuits. So, you can see that there are different types of analog parts that are integrated into modern SOC. And A to D converters and D to A converters are particularly useful, because what happens is we may have sensors such as pressure sensors, okay, or temperature sensors, velocity sensors, accelerometers. In a car, for example, maybe you want to find the pressure, air pressure in the 4 tires. Then you may want to control the temperature inside the car in order to maintain the right temperature by adjusting the AC. You may need to measure the temperature. You may need to measure the velocity and acceleration to find out if the driver is driving the car in a safe way. Okay. So, a lot of sensors are now integrated into cars, and these sensors produce electric signals, right, and we may have to do things like maybe amplify those signals. Okay. We may also want to remove noise. Okay. So, through filtering, okay, maybe that may have to be done before amplification. Okay. So, there may be filters. And then we need to do analog to digital conversion, so that we get digitized values of various things like pressure, temperature, etc. And we may store these values in some memory. And then there may be a CPU which accesses this memory and performs some software processing. Okay. Maybe you want to know what is the current air pressure and display it on the panel, or you may want to adjust the temperature inside the car. So, there are many interesting and useful ways of using all this information and providing some value to the user. So, A to D and D to A converters are very important in this modern day SOCs. Okay. So, you can see that is what they are also saying. whatever I just said has been explained here also, right. So, the analog inputs may have to be filtered for noise, then we digitize. Okay. There is a sample and hold circuit that is used for quantization purpose, and then we convert the analog signals that we get into digital, and a DSP may process them, or a microcontroller may process them, or a microprocessor may process them, right. And occasionally the processed digital values may have to be converted back to analog, right, using what is called as a D2A converter. So, in a lot of applications, whether it is wireless, networking, multimedia, real time, automotive, industrial electronics, in all of them it is very common to find A to D converters and D to A converters. And they are typically used along with these DSPs and microprocessors and microcontrollers. And see, unlike digital testing, okay, so let me just give you an idea of what is different between analog and digital testing. So, Teradyne is one well known company, right. So, you will find that they have different kinds of analog measurements, right. So, this is more like a what are some measurements that are possible. So, things like the multimeter and measurement of current, measurement of frequency, etc., that we talked about in the earlier part of the class, you must revise. Okay.